Nearly every industry uses dangerous chemicals to control some part of their process. Think of ammonia used to mop floors or the acid in dry batteries. These chemicals often pose a direct, well-known hazard, like the explosive power of dynamite used in construction. Other chemicals, like plant fertilizer, pose dangers that are not as clear. A hazardous material, or hazmat, is any chemical or other substance that can harm humans, animals, or the environment. This can be due to the chemical's physical characteristics, its quantity, or its concentration. Chemicals must be managed very carefully at all times to make sure they are transported, used, and disposed of safely. The dangers they pose can be divided into three categories: physical hazards, health hazards, and environmental hazards. Physical hazards pose a risk for acute health effects, which means they can immediately maim, kill, or injure on contact. Physical hazards can be explosive, corrosive, flammable, poisonous, pressurized, and combustible. Explosive chemicals like nitroglycerin or propane have so much energy they can quickly and violently detonate, causing an explosion. Corrosive chemicals like sulfuric acid are so reactive they can damage metals, glass, and human tissue on contact. Flammable chemicals like propane will burn as fuel if heated, pressurized, or given a source of ignition like a fire or an electric spark. Toxic chemicals like chlorine gas can damage internal organs on contact, leading to immediate illness or death. Gases like helium are stored at very high pressures. If its container is damaged, the energy of the escaping gas can launch it like a rocket or even explode. Oxidizing chemicals like hydrogen peroxide can cause other chemicals to combust into a hot, self-sustaining fire. Health hazards come from materials that cause infections or otherwise slowly damage the body over time. These long-lasting health conditions are called chronic effects. Examples of health-related hazards include bacteria, viruses, radiation, cancer-causing materials, and materials known to cause reproductive harm. Cancer-causing materials are called carcinogens. An example is asbestos, which is a fireproof mineral mined from rock. It was once used to make a wide variety of goods, including cigarettes, brake pads, and building insulation. Environmental hazards are those that affect the chemistry of an ecosystem or pose a threat to aquatic life. Many chemicals used in the production of medicines and paints can disrupt or destroy local food chains, thereby damaging the environment and freshwater resources.
Even grease, a common semi-solid lubricant made by combining an additive and a thickener to a liquid lubricant, is a risk to the environment.
A wide range of industries use many types of chemicals to produce goods and services. Therefore, it is important to have a way for people to quickly know the dangers each substance poses, even if they are not familiar with it. Hazardous materials communication standards are regulations that describe how to communicate the hazards of chemicals through labeling and other documentation. Many countries have now adopted an international standard for hazardous material communication called the Globally Harmonized System of Classification and Labeling of Chemicals, or GHS. This international standard has become very important because chemicals are so often transported across international borders. GHS was created by the United Nations in 1992 and is currently used by more than 30 countries, including the United States and Canada. GHS communicates the many types of physical, health, and environmental hazards using symbols called pictograms. These symbols can help people throughout the world recognize hazards regardless of the language they speak. There are 9 pictograms. Toxic substances, compressed gases, pollutants, explosives, corrosives, oxidizers, irritants, health hazards, flammable substances. Toxic substances. This symbol means that the chemical is harmful or fatal if swallowed or inhaled. Avoid exposing it to your body and wash your hands thoroughly after handling it. Examples of chemicals using the skull and crossbones pictogram range from advanced chemicals like hydrogen cyanide to everyday cleaners like ammonia. Compressed gases. This symbol shows that the chemical is a compressed, liquefied, or dissolved gas under pressure. Take caution to ensure its container is fastened upright and cannot be punctured, tipped over, or damaged. The gas container pictogram can be found on nearly every gas from carbon dioxide and helium to refrigerants like Puron. Pollutants. This symbol indicates the chemical is highly toxic to the environment or wildlife. Great care must be taken when using or disposing of them to avoid pollution. Many mixing agents used to create glues, paints, plastics, and rubbers will show this symbol. Explosives. The exploding bomb pictogram means that the chemical can produce an explosion. It includes those that are unstable, self-reactive, or sensitive to heat, pressure, or light. Although some chemicals like TNT are made specifically for explosives, many other types of chemicals, such as propane, can explode too. Common products featuring this symbol are made into fireworks, rocket fuel, and ammunition. Corrosives. This symbol shows that the chemical is corrosive and can damage or destroy whatever it touches, including metal, glass, and human tissue. Corrosive chemicals can exist as solids, liquids, and gases. Common corrosives include hydrogen peroxide, chlorine, alkali metals like sodium, and nearly all acids. Oxidizers. Oxidizers are chemicals that fuel the combustion of another material. Some oxidizing chemicals can also suddenly ignite with the atmosphere without warning, known as spontaneous combustion. The most well-known oxidizer is oxygen itself, but there are many others, like iodine and ozone. This symbol is most often found on chemicals that react with water to make pure oxygen, which makes them extremely dangerous when fighting fires. Irritants. This symbol means that the chemical can irritate the eyes, skin, or lungs if it is touched or inhaled. The effects are usually reversible, but it should not be handled without protective equipment. Note that this symbol is not used if the chemical is toxic or poses a health hazard, since those have permanent effects on the body. The more severe pictogram is used instead. Health hazards. This symbol means that the chemical is known to cause long-term health effects. It includes carcinogens like BPA, as well as those that can cause birth defects like pesticides. Health hazards like radioactive elements and biological hazards like viruses and bacteria are exempt from using GHS pictograms, although they have their own special symbols used for transportation. Flammable substances. This symbol means that the chemical can burn or start a fire. It can be found on solids, liquids, and gases, as well as chemicals that release flammable vapors. Common flammables include gasoline, acetone, hydrogen gas, and compounds used to make plastics like polystyrene. A hazardous chemical label can have as many GHS pictograms as it needs in order to show all of its dangers. It can have as few as 1 or as many as 8. For example, ammonia is a common chemical used to produce food, fertilizer, medicines, and cleaning supplies. In its pure form, It is a colorless gas that can harm the environment. Ammonia is also extremely corrosive. It has a pungent smell and can irritate the eyes, skin, and lungs. It is also highly toxic, so the symbol for poison is shown instead of the symbol for irritant. Compressed gas. Toxic. Corrosive. Environmental hazard. Compressed gas. Toxic. Corrosive. Environmental hazard. Before the United States adopted GHS labeling in 2012, it created its own system called the Hazardous Communication Standard, HCS, or HAZCOM. HAZCOM is controlled by the Occupational Safety and Health Administration, or OSHA. The old HAZCOM symbols look very similar to the GHS system, except the border is black instead of red. OSHA no longer considers the old labels acceptable, since HAZCOM was fully aligned with GHS on June 1, 2016. Before Although the GHS pictograms show dangers of certain chemicals, they do not give any information about what those specific dangers are, like symptoms you might experience after accidental exposure. That is why OSHA's HAZCOM system requires every hazardous chemical to have a safety label that includes more information than just its pictograms. Although there is no exact format that a HAZCOM label must follow, every label must contain the following information: chemical identifiers, signal word, hazard statements, precautions, pictograms, and emergency contact information. The name, address, and telephone number of the chemical manufacturer or distributor must be included on the label. This information is useful for asking questions about the chemical, getting updated information, or contacting them in an emergency. HCS enforces the use of GHS pictograms to visually alert the user about the chemical's hazards. Each chemical must use the pictograms that correspond to its hazard classification. Precautionary statements instruct the user how to minimize the effects of exposure to the chemical. There are 4 types of precautions: prevention measures, first aid instructions, storage measures, and disposal requirements. Hazard statements depend on the chemical's classification and describe the exact dangers it poses. For example, a chemical may be toxic in its concentrated state. The hazard statement would read, fatal if inhaled. In a diluted state, the hazard statement might read, causes damage to the skin through repeated exposure. There are only 2 approved signal words: warning and danger. Danger signals the most severe hazards, and warning is for less severe hazards. Only 1 signal word is used per label. Identifiers are decided by the manufacturer. They can include the chemical formula, the chemical's code number, or even its batch number. Aside from the chemical name, the most common identifiers are the United Nations ID number, or UNID, and the Chemical Abstract Service Registry number, or CASID. The UNID is used for hazardous materials being shipped internationally. HazCom requires chemical manufacturers, importers, and distributors to physically attach a label to every container of hazardous chemicals or to its outside packaging. The label can be glued, fastened, or even printed on the surface of the container, but it must be written in English and displayed at all times. Why is it important for hazardous materials to always have labels? If this label were to feature a fourth pictogram, which would be the most appropriate? GHS and OSHA's HazCom standards both require manufacturers of chemicals to publish a safety data sheet, or SDS, for each chemical to give further detail than the label. The SDS provides information about proper handling, storage, PPE, and disposal of each chemical. Employees should not use any chemical unless they completely understand the information presented by the SDS. HazCom requires every chemical on the job site to have an SDS. Some employers store their SDSs in binders in a central location to keep them organized. Other companies keep a digital database that is accessed through computer terminals. OSHA requires that a copy of the HazCom program be readily available to all employees. This includes container labeling requirements, SDSs, and relevant employee training requirements. Each SDS is required to follow the same 16-section format. The first 3 sections of an SDS contain information about the chemical, its ingredients, and the manufacturer. Section 1. Identification. Section 2. Hazard or hazards identification. And Section 3. Composition and information on ingredients. This section contains the trade name or brand name of the chemical and the name and address of the manufacturer. This section contains a description of the specific dangers of the chemical. Hazards are arranged according to their category, with Category 1 being the most dangerous and Category 4 being the least dangerous. This section contains all of the information used to create its label, including its full chemical name, concentration, GHS pictograms, and hazard statements. Sections 4 through 8 of an SDS describe how the chemicals should be handled, as well as the proper response if something should go wrong. Section 4. First aid measures. Section 5. Firefighting measures. Section 6. Accidental release measures. And Section 7. Handling and storage. This section details the first aid treatments that should be given to someone exposed to the chemical. This section is for emergency response personnel to use to determine how to fight a fire involving this particular chemical. This section provides the necessary information needed to contain chemical spills so they do not affect the environment. This section details the precautions that need to be taken when using and storing the chemical. Section 8 features a table with the permissible exposure limit, or PEL, of the chemical. The PEL is given in parts per million or milligrams per cubic meter. These limits are set by OSHA. This data is often accompanied by a similar number, called the threshold limit value, or TLV. The TLV represents the level of exposure an employee can have in a lifetime of 8-hour workdays without negative health effects. Sections 9 through 11 of the SDS describe specific details about how the chemical interacts with extreme conditions and other substances, as well as its effect on the human body. Section 9. Physical and chemical properties. Section 10, Stability and Reactivity, and Section 11, Toxicological Information. This section details the physical and chemical characteristics of the chemical. It includes things like color, odor, freezing point, and boiling point. This section explains how the chemical behaves under normal storage conditions. It also details specific storage conditions to avoid, such as placing the chemical near materials with which it may react. This section details the effects the chemical may have on specific body parts, including the eyes and skin, internal organs, and reproductive effects. Sections 12 through 15 of the SDS describe how to legally handle and dispose of the chemical. Section 12, Ecological Information. Section 13, Disposal Considerations. Section 14, Transport Information. And Section 15, Regulatory Information. This section explains the effects the chemical may have on the environment, including its effects on wildlife and how long it takes for the chemical to break down naturally. This section explains how to safely dispose of the chemical without putting yourself or the environment at risk. This section explains how to safely package and transport the chemical. This section details all the regulations that apply to the chemical, like what must be done to legally manufacture, transport, store, and use the chemical. The final section of the SDS, Section 16, contains any important information about the SDS itself. This section usually contains the information specific to the company preparing the document, such as the document number and the effective date of the SDS. OSHA requires all employers to inform employees of the chemical hazards associated with the job. The employer must provide at least one 8-hour training session per year that covers SDS materials, hazmat, and chemical safety. Before adopting GHS, OSHA used a similar safety document called the Material Safety Data Sheet, or MSDS. This datasheet was the foundation of the previous HazCom system. The MSDS followed one of two formats. One contained 8 sections of data and one contained 16 sections. The SDS format now used by HazCom is essentially the same as the 16-section MSDS. HazCom no longer considers the MSDS valid, and only the SDS should be used. What is the proper way to destroy small quantities of aluminum oxide? According to the SDS shown, what effect or effects would you experience after brief exposure to the chemical? Using the SDS shown, determine which of the following statements are true. Before HazCom aligned with GHS, there were two other hazmat systems for labeling chemicals. These systems are still found in some workplaces in addition to HazCom, but their use is completely voluntary. NFPA 704. The National Fire Protection Association, or NFPA 704 Fire Diamond, deals specifically with materials in the presence of fire. It helps firefighters and other first responders identify chemical hazards in emergencies. The NFPA and HMIS systems have more differences than just their shapes. While they are not identical, they do have some similarities. For one, their labels are divided into 4 sections that share similar names and color codes. Both systems also use the same 0 to 4 rating scale for hazard levels. A 0 is for minimal hazards and a 4 indicates extreme hazards. Health. Flammability. Instability. Special hazards. Personal protective equipment. Physical hazard. Flammability. Health. Note that the NFPA and HMIS rating scales are the opposite of the GHS category scale. On the GHS scale, a rating of 1 is an extreme hazard, but the NFPA and HMIS systems would use a 4. The blue subsection of both the NFPA 704 and HMIS labels communicate the health hazards of the material. However, they represent these hazards differently. The NFPA health section communicates how life-threatening the material is to nearby firefighters after short exposures. The HMIS health section rates how toxic the material is for employees through daily exposure. An asterisk next to the numeric rating indicates that the material can cause chronic health problems, like kidney damage. The red subsection of both the NFPA 704 and the HMIS labels communicate the flammability of the material, but the two systems work differently. The red section of the NFPA label tells firefighters how quickly the material can vaporize or combust when consumed by a fire. HMIS uses the red section to inform workers how hot the material must get before it can ignite. The yellow section of the NFPA label is called the instability rating. It tells firefighters how explosive the material is in a fire. The orange section of the HMIS label is called the physical hazard rating. It uses OSHA's guidelines to explain how easily the material or its container causes injuries through physical contact. Examples of physical hazards include pressurized gases, chemicals that react with water, and oxidizers. These materials injure by exploding, creating violent chemical reactions, or suddenly igniting in air. The white diamond in the NFPA label is called the Special Hazards section. It uses 3 approved symbols to communicate the special concerns to firefighters. The white box in the HMIS label tells workers what types of PPE are needed to safely handle the material. A letter is always used, but symbols of the PPE equipment can also be included. Special hazards. OX is an oxidizer that can greatly fuel a fire, making it harder to fight. AW with 2 lines through it means the chemical has an unusual reaction to water, so something else must be used to extinguish the fire. SA is a simple asphyxiant gas. If it is released from its container, it can suffocate the firefighters by pushing oxygen out of enclosed areas. Personal protection. HMIS uses the letters A through X as a shorthand way to list one or more types of PPE. The chart for A through F is shown here.